Welcome everyone to section 8.5, Law of Sines. This is for geometry. This is a super useful section where we can find the angle or the measurements of any sides of any triangle. It doesn't have to be 90 degrees. Let's go ahead and get started. Now, here's the law of sines, and I haven't wrote it in yet because I want to do a quick proof. So I don't do this often, but I think this one's quick and easy, so let's go ahead and start. So let's say we have a triangle, and we have no clue what these angles are, and we don't know it's a right triangle. Boy, that was a fail in terms of circles. Okay, anyway, besides that, so what we can do here is we can draw a height and make it into right triangles, okay? So then we would have a right triangle here with this angle A as one of the angles, okay, and then we'd have a triangle over here with angle C. Okay, so I wanted to separate out into C and A. Now, how would we find the sine of A for that yellow triangle we just drew right here? Well, our opposite side for sine would be H, so we would have H as our opposite sine, and then C would be our hypotenuse, okay, because it's opposite the 90-degree angle. So it would be H over C for sine of A, and I used the wrong color. I wanted to use, whoops, a little messed up here. Let me fix it. Okay, so then we have C for the hypotenuse. Now, for sine C, what would it be? Well, opposite side, okay, this would be our opposite side there for C, and our hypotenuse would be over here. Okay, so what would the sine of C be equal to? Sine of C would be equal to, again, H would be the opposite side, and then our opposite side, or excuse me, our hypotenuse would be A. So again, hypotenuse, opposite. For A, this again is our opposite. They both have the same opposite side in our hypotenuse. Okay, just to give an idea. I'm going to erase this. Pause it if you want to take a look. Jot this down. Okay, I'm going to erase it because I don't want that there later. Okay, now what I can do here is I can solve for H for both of these. So what I do, I multiply both sides by C here. I get C times sine of A equals H. Okay, and then I'm going to multiply, I'm actually going to flip this one. So I'm going to multiply both sides by A, but I ran out of room a little bit. Okay, so what do I get on, I'm going to change it to the left side. H equals, and then I had, for more room, I have A times sine of C. These A's cancel. These C's canceled. So then I have C times sine of A equals H, and then H equals A times sine of C. Well, since they're both equal to H, I can set them equal to each other. So this guy, whoops, this guy is going to be equal to, oh, dang, this guy is going to be equal to this guy because they're both equal to H. Okay, now that they're equal to each other, what can I do? Well, I can divide both sides by, let's see, what should I divide by? I'm going to divide by sine of C to both sides. Okay, I'm going to divide by sine of C to both sides. And what happens? It cancels here. And then I have C times sine of A over sine of C. But I don't like that sine of A on the left side, so I'm going to get them over onto the other side by dividing by sine of A to both sides. So what's my final answer? Well, I get C over sine of C is equal to A over sine of A. This is important because we have your angle and opposite side together in a ratio, and what happens is this is the law of sines. So the law of sines is A over sine of A is equal to C over sine of C. Oops, sorry. I'll put that over here. And it turns out this works the same way with B. So this works with all three angles. So B over sine of angle B. That is our law of sines. And actually you can even flip it. You can have it sine of A over A equals sine of B over B. It's the same thing. Sine of C over C. Okay? Where this is the top number. So top is a side, and then the bottom is an angle. Okay, the sine of an angle. But I just want to be clear that that's a side length there. Okay, how do we apply this? Well, we have, oh, sorry, forgot one last thing. This is good for when we have an angle, a side, and an angle, or two angles and a side given together, okay? This is important because we can't always use law of sines or situations where you won't be able to solve for the proportion. We're missing some things because you have to, if you're trying to solve, you have to have at least three things given. For example, and this is just a quick aside, you can fast forward this if you don't want to hear it. If we have a ratio here, A over sine of A equals B over sine of B, you only can concentrate on one equal sign at a time. If we have three pieces of information, we have boom, 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 we have all those three things given, we can solve for the last thing, B. Okay, but if you have two things missing, you can't solve for it. You need at least only one thing missing per proportion. Let's go ahead and apply it to example 1. So example 1, what do we got going on? Well, we can label this triangle ABC if we want. We don't have anything labeled. Might help us to label it. So let's go ahead and start with that. Let's call this A, B, and C, capital letters. So opposite A is going to be little a, opposite B is going to be little b. Okay, right now it's X, so I'm going to leave them X. And actually, I'm going to change this to X here, just so it's a little bit more clear. That's a big X. And then this is a little c. Now, what do I have going on here? Well, what I want to do is I want to circle like pairs. I want an angle and a side pair for each one of these. And I need two of them, one of them being the desired information. So I have here, that's our given, okay, that we're looking for. And then here's the one we're desiring. This is the one we're missing. Notice how I have two things circled. I have a given angle, okay, but a missing side. That's our missing side. We only can have one missing piece of information in these two circles. Here we see that we have a given angle, given side. That's good. We have a given side and then only one missing piece of information, so we're good to set up our proportion. What does this look like? Well, let's go ahead and set this up. In our blue, let's start with blue, the givens. We know that we know that 15 over sine of 93 is going to be equal to X, that's our side there, over sine of X, which is 48. Let me go ahead and I'm going to do one step back a second. So we know that sine of C over C is going to be equal to sine of X over X, where the big letters are our given angles. Oh, I wrote it backwards. Whatever, it's the same thing. So let me go ahead and switch that real quick for you so you don't get confused. So here we have C over sine of C is going to be equal to X over sine of X. Okay, so that's, and then we just plugged in the value. So you can see here that we have values given here, here, and here, and we only have one that we're looking for. We're good to use this proportion. Law of sines will work for this one. So let's go ahead and cross multiply and then divide. So here we have 15 times sine 48 equals X times sine 93. What I like to do is I don't like to touch this until I solve for X. So I'm not going to type any of that in the calculator yet. I'm going to divide here first to get X by itself. Okay, so here I have X by itself now. I have X equals, and this is where I use the calculator. So I'm going to plug this into my calculator now, and I'm just going to type it as I see it, and that's going to lead to my answer. So I'm going to type in 15 times sine of 48, and I'm going to hit enter after that, and I'm going to hit divide because it stores it automatically. I'm using the TI-84 Plus, TI-84 Plus. If not, you might need to just take a few more steps with this if you don't have this particular calculator. Sine of 93. So I divide this by sine of 93, and I get 11.162 as my side length there. So now I know X is 11.162. And I'm just going to double check my work. So I have 15 sine of 48. Okay, 11.14, and then I'm going to divide this by sine of 93 degrees. Okay, and I get the same thing. Okay, 11.162. 2 is my length, and that's whatever the units are, meters, feet, whatever. Okay. Now, example 2, before we get to we're not going to do law of cosines today. Example 2, which angle can we find? Okay, this is a good way of understanding what we can do with law of sines. So first off, notice how we have an angle and its opposite side. That's what we're looking for here. That's 1. That's given, okay? Now, we have to have only one piece of information. So let me do the wrong one first. Here, we don't have the angle, so we could technically find it, but we also don't have the missing side. So we're having a missing side and a missing angle. That's no good. We can't do that, okay? So we're not going to find that piece of information yet. We can do it later, but not yet. Oh, no, we can't find it. Yeah, we can do it later once we find the other angle. Okay, so then what we're going to do here is we are going to take, okay, since we can't find that side, well, what about this angle and this opposite side? Do we have one of those pieces of information? And the answer is, yes, we do. We have the opposite side. We just have a missing angle, so we can set up the law of sines. I'm going to set it up the other way this time. So we can say the sine of 120 over 18, again, it doesn't matter which one, as long as you're consistent and keep the signs on the top on both sides, or on both sides on the bottom, is equal to the sine of our missing angle. Let's call it A. So let's call that, big A. Let's call this big A and this little a, and then we can call this guy big B and this guy little b. Okay, so then sine of A, which we don't know, we have a missing angle here, over 11. We're already set. We only have one piece of missing information, okay? So we had given, good there, given. Then we had given, missing. We only have one piece of missing information. We're set, okay? So now we can cross multiply, and what happens? We get 11 times sine of 120. Again, I don't type this in the calculator until I have A by itself, equals 18 times sine of A. Well, this is going to be a little bit more challenging. This is going to be a two-stepper. So I divide by 18 first. I have 11 times sine 120 over 18 equals sine of A. Now, what I do is I leave it in my calculator. I don't type it in my calculator just yet, but just for the sake of simplicity, so you understand what I'm doing, I'm going to go ahead and multiply this out times sine of 120 divided by 18. So I get 0.529, okay, equals sine of A. Now, how do you get rid of the sine of A? Well, we have to inverse sine it to get the A by itself. So I have to inverse sine both sides. Okay, so what I'm going to end up doing is I get A by itself because I inverse signed it. And now I need to go to my calculator, inverse sine that decimal. It's already stored on mine. So I'm just going to go up and select it, and I get 31.95 degrees. So 31.95 degrees is equal to our angle measurement. What's cool about this is now we can find our last angle measurement. 31.95. I can find it by doing 180 minus 120 minus 31.95, and then I can use the law of sines again to find that missing side. Okay. Real quick, just so you know what I'm talking about. Well, let me first round this to 32. I'm going to call this 32, just for simplicity's sake. Okay, so then I can do 180 minus 120 minus 32, and I can figure out that this guy is 28 degrees. Now, if I wanted to, I could set this up and call this guy C, and say, okay, sine of 28 over C is going to be equal, and we can use either one. I'm going to use my green one, which is sine of 120 over B, which was 18. So now I can use the law of sines again if I wanted to. I'll do that real quick. 18 times sine 128 divided by sine 120, and I get C equals 9.76. So I can find all the missing sides just with the law of sines, okay, which is pretty useful. That's all there is in this video. Be sure to leave a comment if you have any questions or you want me to call any questions. So technically we could find both angles, okay, but in the first step we could only find angle A, which we labeled there. Lots to cover here. Very useful concept. Thank you so much for watching. Be sure to check out 8.6, Law of Cosines, after these messages.